In lesson 5.4, we're going to learn about another type of display that we can use for numerical data, and that's called a box plot. And we're also going to learn how to compare two different distributions. So in addition to dot plots and histograms, numerical data can also be displayed using a box plot. Sometimes we call this a box and whisker plot. And a box plot is simply a visual representation of something called the 5-number summary. Now, our calculator will do the 5-number summary for us, and we've already used some parts of the 5-number summary. The 5-number summary includes the minimum value in a data set, the first quartile, the median, the third quartile, and the maximum. So those are just sort of some kind of markers in our data set that give us some information about how our data is distributed. Now, a box plot or a box and whisker plot looks like this little diagram that you have drawn in your notes here. So we have a box in the middle, and then we have the whiskers on the end. And the left tail of the leftmost whisker represents the minimum value. The left edge of the box represents the first quartile. The line in the middle of the box represents the median. The rightmost edge of the box represents Q3, and the right end of the rightmost whisker represents the maximum value. Now, in this box and whisker plot, this data is not symmetrically distributed. You'll notice that the median is not exactly halfway between Q1 and Q3. And it can be, but it does not have to be. But no matter how those data values are distributed, each portion of the box and whisker plot represents the same percentage of your data. So the smallest or the leftmost whisker represents 25% of your data. This part of the box represents 25%. This part of the box represents 25%, and the rightmost whisker represents the last 25%. So altogether, it's 100% of your data, just divided up into those 4 sections. Now we're going to make a box and whisker plot with the West Ottawa High School football data that we've used earlier in this chapter. You can go ahead and put those numbers into the list in your calculator, and then use your calculator to find the 5-number summary. And remember, you're going to hit the stat button and go over to calc and choose one variable stats. And then if you scroll down, you'll be able to see the 5-number summary. So the minimum is 20, Q1 is 27.5, the median is 33.5, Q3 is 38, and the max is 48. Now, when you make your box and whisker plot, you need to go ahead and label your scale, and I just counted by 5s there. That will fit all of those values on our 5-number summary. Your scale should be consistent, so you're not labeling it according to your data or according to your 5-number summary. You want to just stick with a consistent scale. And then these 3 numbers in the middle represent the box in your box and whisker plot. So what I'm going to do is I'm going to draw in the left edge of the box, so that's 27.5. There's the median, which will be the middle of the box. That's at about 33.5. And the rightmost edge of the box is at 38. And then I'll connect those. The leftmost whisker then will go down to 20. And the uppermost whisker will go up to 48. So that's how we draw a box and whisker plot. Now we're going to do the same thing with the NASCAR data from the last lesson. And remember, in the last lesson, we calculated that 200 was an outlier. When we have a data set with outliers, we want to show those on the box and whisker plot. If you go ahead and put those numbers into your calculator and find the 5-number summary, the minimum is 50, Q1 is 54.5, the median is 83, Q3 is 88.5, and the maximum value, of course, is 200. So here I am counting by 20s because I need to go all the way up to 200. You can also start your scale at 50 and just maybe go from 50 to 200, and then you can maybe count by a smaller number if you'd like, but either way is fine as long as you're using a consistent scale. I'm going to put the markers in there for the middle 50%, the box part of the box and whisker. So this leftmost line is at 54.5. This one is at 83, and then 88.5. So notice this is an example of one where the median is close to Q3, and the data is a little bit more spread out on the left-hand side. Now, the leftmost whisker is going to go down to 50, so it's going to be very short. On the upper end, we have an outlier at 200, And then the next data value that's below 200 is this 105. So when you show that on your box and whisker plot, you're going to put a dot or maybe an asterisk, we use those sometimes, at that outlier. And then your whisker is only going to go up to 105. And I'm going to label that on there. You don't have to label it, but I'm just putting it in there so that you can maybe remember in your notes why we stopped the whisker at that point. Now that 200 is still the maximum value. So if you were going to find the range, you would still do 200 minus 50. You would not just stop at 105 because the 200 is in fact the maximum value, even though it happens to be an outlier. Now, we often use side-by-side box plots to compare different features of two or more distributions, and that's what we're going to do in example number 3. So we've given you some side-by-side box plots for the short and long putter data that we used earlier in this chapter, and we're going to use these box plots to answer some questions. Notice these, by the way, are giving you they've drew some lines at the end of the whiskers, which is sometimes you'll see that, or sometimes you'll even see like points there just to kind of make it real clear where that line is stopping. Whether you include those or not, it really doesn't matter. They're just some options on different ways to draw those. So let's talk about how to compare these. Well, the first thing we're going to do is answer some questions about how the data is distributed. So for part A, it says, what percent of the putts with the short putter were at least 50 inches from the cup? So we're looking at the short putter. 50 inches is right about here. And that looks like it's the third quartile. So at least 50 means 50 or more. And so that would be 25% because that would just be this whisker that's above 50. What percent of the putts with a long putter were between 0 and 13.5 inches from the cup? Well, now we're looking at the long putter, and 13.5 is right about there. So between 0 and 13.5 is the whisker and the first section of that box. So that would be 50% of the putts. Part C is asking us how the shapes of the distributions compare. I would say in this case, both of these distributions are slightly skewed to the right. The reason we're saying that is because the median is closer to Q1. This whisker is really short. So the 50% of the data that's over here is pretty closely grouped together. And then this data is a lot more spread out. And the same thing is true for the short putter. So they're skewed to the right. How do the centers of the distributions compare? Well, the only measure of center that we can see in a box plot is the median. So when we're talking about the centers of distributions and we're given box plots, we want to compare the medians. So the median here is a little bit lower than the median here. Not by a lot, but it is a little bit lower. And so when we want to compare them, we want to use comparative language like greater or less or something like that. So I would say the median for the short putters is bigger than for the long putters. And then part E is asking us about variability. Variability would be either range or the IQR, and we can see both of those pretty easily from a box plot. Notice for the short putters, the range is a little bit greater. Also, the IQR is greater, and we can tell that because the IQR is represented by the width of the box, this middle 50% of the data. So we would say that the short putters have a larger range and IQR. So again, with variability, you want to address either one or both of those two measures. Again, with center, we're only looking at median because we can't tell the mean from the box plot. Please do homework 5.4 from your assignment packet.